Hey everyone, welcome back to the series. In this final step of building our neural network class, we're going to implement two very useful features: saving the model to a file and loading it back. This is important because we don't want to retrain the model every time we restart our program. And the model will be like this. This is a CSV file, and we're going to save the weights and biases like this. Let's start with saving the model, and we create a method called saveModel. Void saveModel, and it takes const std string reference file name equals model.csv, and we say const at the end, which means this method won't modify the object. This method saves all the weights and biases to a CSV file, so they can be reloaded later. Then we open the file to save the model data, and we say std or fstream file, and we pass it file name. If the file doesn't exist, it will be created automatically. If it exists, it will be overridden. After opening the file, we check if it was successful. If not file.is_open, which means if the file couldn't be opened for any reason, we print an error message. And here we say std cerr, and we print unable to open file. And here we print the file name and new line. Then we exit the function early, return. And here I'm gonna say file, stream insertion operator, and type, comma, layer, comma, row, comma, call, comma, value, and /n. This is the CSV header. It tells us what each column means, whether it's a weight or a bias, what layer it belongs to, and its position and value. Now we loop through all the layers to save the weights and biases, and we're gonna start from the first hidden layer. And here we say for size_t L equals 1, the first hidden layer, and L less than layers.size and ++ L. Then we loop through the weights. For size_t I equals 0, I less than weights square brackets L-1 dot get rows. We use L-1 because we want to start from the first weight matrix, the connection between the input layer and the first hidden layer, and ++ I, and the inner loop for size_t j equals 0, j less than weights square brackets L-1 dot get calls and ++ j. Inside the inner loop, for each weight we write its layer number, row, column, and value to the file, marking it as a weight in the first column. And we do it like this: file, weight, this is the first column, L, and comma, I, comma, J, comma, weights, L-1, I, comma, J. Then we add on /n. After writing the weights, we loop through and save the biases for the current layer. For size underscore ti equals 0, I less than layers square brackets L dot bias dot size and plus plus I. And inside the loop, file bias comma L comma I, and here we use 0 for the column since biases are stored as 1D vectors. So we say comma 0 comma and then layers square brackets L dot bias square brackets I and slash n. Finally, we close the file and print a confirmation message. File.close and std cout model save to, and here we print the file name and std int L. This lets us know the model was successfully saved to the given file. Now let's add a method to load the model back from the file. And here we create a method called loadModel. Void loadModel, and it takes const std string reference file name equals model.csv. This method reads a previously saved CSV file and restores all the weights and biases. Here inside the method, first we try to open the file. std ifstream file, and we pass in file name. Then we check that the file was successfully opened. If not file dot is underscore open, if it can be opened, we print an error message and exit. std cerr unable to open model file, and file name and std int L. Next we say return. Now we declare a string to hold each line we read from the file. std string line. Here we skip the first line because it's just the CSV header, not the actual model data. So we say std getLine and we pass in file and line. Now we look through the rest of the file line by line. While std getLine and we pass in file and line. Inside the loop, we use a string stream to parse each line from the CSV file. std string stream, and we're gonna call it ss, and we pass in line. Then we declare string variables to hold the CSV fields. std string type, comma layer str, comma row str, comma col str, and comma value str. Here we use std getLine with the string stream ss to read the next value from the line, stopping at the comma. std getLine, and we pass in ss, comma type, comma, and inside single quotation, comma. This extracts characters from ss until the first comma and stores that chunk in the type variable. Let's do the same for the rest of the fields. Each call grabs the next value from the line, splitting the CSV into separate variables we can use. Now that we have all the fields as strings, we convert them from strings to actual numbers so we can use them to update the model. Next, we check the type field to see whether the line is for a weight or a bias. If type is equal to weight, then we say weight square brackets layer -1 and inside parentheses row comma col equals value. And here we use layer -1 because there is always one less weight matrix than the number of layers, as weights hold the connections between layers. Then if it's a bias, else if type is equal to bias, and here we say layers square brackets layer dot bias square brackets row equals value. Finally, we close the file and print a message confirming that the model was successfully loaded. File.close and std cout model loaded from filename std.int. And that's it. With these two methods, we can save our trained model and load it anytime later, making the neural network more practical for real-world projects. In the next video, we'll create a file called csvloader.hpp to handle reading and preparing our dataset. You can download all the project files, including the dataset, source code, and log files from my GitHub. The link is in the video description. If you are enjoying the project, leave a like, subscribe, and turn on notifications so you don't miss what's coming next. Thanks for watching, and I'll see you in the next one.